number? Today, we're diving into the elegant proof that shows why this simple-looking number defies simple fraction form. Imagine trying to measure the diagonal of a perfect square with a ruler. You'd find it impossible to land exactly on a simple fraction. That's the essence of irrational numbers. Our journey begins with a powerful technique called proof by contradiction. We'll assume the opposite of what we want to prove, and then show that this assumption leads to an impossible situation. If we assume the square root of 2 can be written as a fraction p over q, where p and q are whole numbers with no common factors, then we can square both sides of our equation. This simplifies to p squared equals 2 times q squared. Now, let's think about this equation. If p squared is equal to 2 times q squared, it means p squared must be an even number. And if p squared is even, then p itself must also be an even number. If p is even, we can write it as 2 times some other whole number, let's call it k. Now, let's substitute this back into our original equation. This simplifies to 4k squared equals 2q squared, which means 2k squared equals q squared. And just like before, if q squared is equal to 2 times k squared, it means q squared must be an even number. And if q squared is even, then q itself must also be an even number. But wait, we started by assuming p and q had no common factors. But now we've shown that both p and q are even, which means they are both divisible by 2. This is a contradiction. Therefore, our initial assumption must be false. The square root of 2 cannot be written as a fraction of two whole numbers. It is an irrational number.